Welcome back to Topic 3 for Algebra 2, Write, Solve, and Graph Linear and Compound Inequalities. In Part 1, we're going to focus specifically on linear inequalities. Before getting started, let's review some key inequality symbols. The greater than symbol looks like this, whereas the less than symbol looks like this, kind of like a slanted L. If something is greater than or equal to, we have the greater than symbol with a horizontal bar underneath it, indicating or equal to. So it could be bigger than that value, or it could be equal to that value. Similarly, with less than, we have the less than sign and then the or equal to bar. If something has a closed circle, then that means the endpoint is a solution. We find that the endpoint is a solution when we deal with either the greater than or equal to, or the less than or equal to. So whenever we have that horizontal bar that indicates or equal to, so that endpoint could be a solution. On the other hand, we have an open circle when an endpoint is not a solution. We see this with strictly greater than or strictly less than. Now, when shading your inequalities, a helpful tip is to shade in the direction that the arrow is pointing. If we look at our inequality kind of like an arrow, it can point in the direction that we want to shade in. However, this only works when the variable is on the left-hand side. Let's graph some examples. Our first example, we have x is greater than -5. So on your number line, feel free to mark -5. You do not have to have 0 in the center, but you do need to mark the value where you are starting. Since x is greater than -5, it is strictly greater than, so we're going to have an open circle and we're going to shade to the right. For number 2, x is less than or equal to 3. We're going to have a closed circle since it's less than or equal to, and we're going to shade to the left, all the values that are smaller than 3. Now, sometimes we need to solve some inequalities first before we graph them. If you add or subtract by the same number from both sides, the inequality remains true. If you multiply or divide by the same positive number, the inequality also remains true. However, if you multiply or divide by a negative number, then the inequality sign must flip, or else the inequality will not be true. Let's look at some examples. Our first example, we have -9x is greater than or equal to 45. On both sides, we're going to divide by -9. Just like when solving linear equations, we want to isolate our variable, we are going to do the same thing with linear inequalities. So we'll divide both sides by -9. On the left-hand side, we'll have x. On the right-hand side, we have 45 divided by -9, which gives us -5. Almost spelled that answer. However, because we divided by a negative number, our inequality sign must flip. So instead of greater than or equal to, now we have less than or equal to. So again, on my number line, I'm going to mark -5. Since it's less than or equal to, we're going to have a closed circle and then shade to the left. For example number 2, we have 4x plus 9 is less than 25. This is a two-step linear inequality. So we're going to subtract 9 from both sides and get 4x is less than 16. Now we can divide both sides by a positive 4, so our inequality will not change, and we get x is less than 4. Since x is strictly less than 4, we're going to have an open circle and shade to the left. And that's it. Thank you for watching topic 3 for Algebra 2, writing, solving, graphing, and, write, solve, and graph linear inequalities. Thanks for watching.